So, have you ever heard about the word quantum entanglement? What is it? I'll tell you.
Before talking about that, we have to know what quantum mechanics means.
So, quantum mechanics comes from two terms, quantum and mechanics. The first word means the discrete particle of something, or the smallest amount that we can get from matter. And the word mechanics refers to the motion of those particles.
Okay, let me use an example to describe what quantum is. Imagine a large truck loaded with about 2 tons of fine-grained sand, and let's assume it's measured by a super-sensitive scale. With this scale as our measuring device, the gain or loss of a few grains of sand from the truck would be too small to be measured. A spadeful of sand might be added or removed with no change in the scale reading. Okay, now imagine a tiny little truck operated by a driver of the size of this tiny ant. In this microscopic world, the load on the truck can be added to or decreased only by rolling on or off one or more grains of sand. On the scale that weighs this tiny truck, even 1 grain of sand represents a substantial fraction of the load and is easily measurable. So the grains are the discrete particles of the sand. We usually don't refer to electrons as particles, but rather as waves at the quantum level. Then, by what means can we measure them if they're like waves? To solve this problem, we use something we call a wave function, that is a mathematical description that helps us to depict the properties of electrons. The amplitude helps us to know the position, and the wavelength to know the momentum of the electron. But we cannot know both at the same time. We know the momentum of this electron because it has a constant wavelength, but we cannot know the amplitude since it's infinite. As for this wave function, it has a constant amplitude, so we can know the position, but not the wavelength because it's not determined, so we don't know the momentum. So we can know them at the same time. This leads us to the uncertainty principle. Okay, let's imagine if I have 2 boxes, a green and a blue one, and I put them in different boxes. If I give you one box and you open it and discover that it's green, then we immediately know that the one I have is the blue one. That kind of describes what happens to the electrons at a quantum level. To have a better understanding of entanglement, we have to deal with the fact that electrons don't have a definite property unless measured. For the measurement, we know that they are in a superposition. For example, when we toss a single dice in the air, we cannot know its distinct face unless it lands.
Okay, suppose we have 2 electrons and they are entangled. The measurement that we make on one of the electrons causes its pair to simultaneously exhibit the properties in opposite manner. So no matter how far the electrons might be, we can know the information about the other electron if we can measure one of the properties of the other.